Alright everyone, we're going to be looking at two-way tables today. So here we have a two-way table representing the number of students that preferred maths or English, divided into two different groups, Year 9 and 10. Okay, so let's learn to read this table. So the first question, how many students were surveyed? That's just all the numbers added up all together. So that's 12 plus 15
plus 14 plus 6.
47. Okay, so there are 47 students altogether. Now, how many students were from Year 9? So the total number of Year 9 students, if you look over here, that's all my Year 9 students if you read across. So that's 12 plus 15, which is 27. Okay, so that's my answer. Similarly, they ask you how many students were from Year 10. Year 10 students are here, and all these students are from Year 10. So 14 plus 6, that's 20 students altogether that were surveyed that were from Year 10. Okay, now let's have a look at the total number of students that preferred maths. Maths is here, so all the numbers below maths represents the students that prefer maths altogether. So 12 plus 14, that's 26 students. Okay. Similarly, the total number of students that preferred English, all the numbers under English, 15 and 6, which makes 21, preferred English altogether. Alright, now let's have a look at some probability questions. So it says, what is the probability of choosing a student who is in Year 9 and prefers English? So let's locate what that number is. We've got Year 9 here, and we've got English there. So if we locate that number, that's 15. So the answer is 15 over the total number of students, that's 47. Okay, so that's your answer as a probability. Similarly, the probability of choosing a student that prefers maths is in Year 10. So we got maths in Year 10, so that's 14. Okay. Now you can't simplify those two fractions, so just leave it as it is. But if you can, obviously write the simplified form. Find the percentage of Year 10 students who preferred maths. So they only want you to look at Year 10 students that preferred maths. Alright, so we know in total there are 20 Year 10 students, and of these 20 students, 14 preferred maths. Okay, so that's your answer. So 14 out of 20 Year 10 students preferred maths, times that by 100 because they want the answer in percentage, so that's 70%. Okay? Similarly, if a Year 9 student is selected, so we only look at the Year 9 students, out of 27 students, yeah? What is the probability that he or she prefers maths? So in Year 9, 12 students, because that's under maths, prefer maths. So the answer is 12 out of total number of Year 9 students, that's 27. Okay? We're not going to times by 100 here because they just want the probability, not the percentage. Okay, let's have a look at some trickier questions now. So what is the probability of choosing a student that's in Year 9 but does not prefer maths? Alright, let's look for that number. So Year 9 students here, and if the student doesn't prefer maths, that means the student prefers English. So their number is 15. So as a probability, that's 15 over 47. Alright? Now next question. What's the probability of choosing a student that's in Year 9 or prefers English? Now if it says the word or, you have to add all the numbers in Year 9 and all the numbers in English. So, all the numbers in Year 9 is across here, 12 and 15. And all the numbers for English, that's under English, so 15 and 6. So we have to add 12, 15 and 6. Okay, and that's going to be 33. Okay, and once again as a probability, that's 33 out of 47. So same thing with the next question. It says, what's the probability of choosing a student that's in Year 10 or prefers maths? So let's add all the numbers in Year 10. So in Year 10, that's all the numbers here across, 14 and 6. And all the numbers under maths, that's 12 and 14. So we have to add 12, 14 and 6. That's 32 students, which is 32 out of 47. Okay? How many students are in year 9 or prefers maths but not both? Let's just have a look at the question up to here. Let's add all the students in year 9 and maths. So all the students in year 9 across here, 12 and 15, and all the students under maths, that's here, that's 12 and 14. So I've got to add 12, 15 and 14. Okay, now with the next part of the sentence, but not both, what you got to simply do is you got to get rid of the 12 because 12 students here is both year 9 and maths at the same time. Okay, so we don't want that number included in our calculation. So that's our answer, 15 plus 14, which is 29. So that's just 29 out of 47. Okay, we want to be doing the same thing in the next question here. How many students are in year 10 or prefers English? Let's just look up to here. So year 10 students, that's all the numbers across here, 14 and 6. And all the numbers under English, that's 15 and 6. So 14 plus 6 plus 15. Okay. But how many students are both in year 10 and English? So year 10 and English. So 6 students are both in year 10 and English at the same time. So we want to get rid of the 6. Okay? So that's 29, which is 29 out of 47. Okay?